Welcome to Spring LIB.
Okay, so we have a thin film of soap and it's on glass, and we want to know how thick is it, given that we know that the red light is mostly reflected. So let's go ahead and draw it out first. So here's the glass, here's the soap, and then, of course, not really to scale. Well, maybe if you're zooming in. And 152 and 134. Actually, I'll write that on the side for this. So let's think about why red would reflect better. So in general, if you have, when we're trying to figure out the reflection properties of different colors, we're concerned with the interference between reflections from the top surface, like this, and then the interference of those with the rays that go through the soap and then come out. So it's these two, and we're concerned with if they're in phase or not. So we're seeing all this red, we know that they're constructively interfering. And so we can say that the phase difference between them is some integer multiple of 2 pi. So 2 pi m, where m is some integer. And we can set this equal to the phase difference between the two. So why are they going to have a phase difference? Well, this wave is traveling through this space. So that's one reason. So that's going to have a phase shift of 4 pi nt over lambda. So basically that comes from the fact that the phase of a sine wave is equal to 2 pi over lambda times x. And so lambda goes to lambda over n. So within here, okay, actually let's label this NO for N oil. And then x, the distance that it travels, it's twice the thickness. So we can say that this has some thickness, and it's 2t. Hence, so that's how we get this. And then this second wave is also getting a phase shift because it's reflecting off of a surface and traveling back towards one of the lower index of refraction than this. So if this was n equals 1, then you wouldn't have this phase shift. But since it's 152 is bigger than 134, then you do have a phase shift of pi. Now, we have phi 1, so is this undergoing any phase shift that phi 2 isn't, or that photon 2 isn't? And the answer is yes, because again, this one is reflecting from this surface. And so we want to subtract that phase shift, again, where this is a higher index of refraction than up here. And so these nicely cancel, so it makes our equation pretty easy to solve. So then we get that T, the thickness, is equal to, let's see if it was 2 pi m. And so it probably said something about minimum thickness. Let's just say that, let's just assume it's a minimum thickness. And so, because all the other problems have basically said that. And so then you can do T is equal to, oops, should have put the 2 over here. And T is equal to lambda over 2 n. So let's go ahead and calculate that. Oh yeah, and then that's NO because it's traveling in the oil, not the glass. So 643, I kind of remembered a factor of 4 being there, but it's not what I'm getting now. This book has the answer, so I can always double check. Okay, so I'm getting 240 nanometers. Let me just check that in the book. Oops, it's taking me a second to open, so I'll pause the video.